My name is Andreas Jäger. I work at SUSE as a product manager. In my former life, I worked as an engineer and have was responsible for the development team that ported Linux to AMD, at that point AMD's x86-64 platform. As part of that, I ported the C library to x86-64 and was also involved with the compiler and the binutils on that one. And that's why I still have some responsibilities as product manager for the toolchain today. But I'm not anymore an active developer, so I'm a little bit further beyond that. Programming languages-wise that I'd like to talk about is a few of those: C, C++, Fortran, and Go. I know there's lots of more, and Toolchain is lots of more options what you have. But that's the GNU Toolchain on the one hand, and with Go, also a very popular language that I want to talk about and explain how we are doing it and how you can use it with SUSE Linux Enterprise server. If you wonder why go with a new compiler, some of the reasons for that is you have new hardware that you want to take advantage, and that comes with new instructions with different ways of that can somebody close the door, please? Thanks. Come in and close the door behind you. Okay.
I'll just see if there's some more folks come in.
Okay. Hannes, come in.
I'm presenting in the next room, and I have 3 participants.
Oh! Hannes, should we merge the presentations? Okay. Yes, is that not probably working? Or?
Yeah, I can hear it.
You won't hear it here. It just goes on the recorder.
Okay. Good. So, taking advantage of the new compiler toolchain, Intel is bringing up every year a new compiler, a new CPU generation that contains some new instructions that ask for different scheduling ways of running, ordering the instructions, and you might want to take advantage of those. And the same happens with IBM and Power and Z and ARM, where new hardware might need new optimizations. But also the teams are working on improving the compiler itself to provide more superior optimizations. And why did I write up 2 times compiler optimizations? The third thing that's also important is diagnostics, new language features coming into the language and taking advantage of those. So that will help you write improved diagnostics and write better codes that works in more places. We have with SUSE Linux Enterprise 12 introduced the so-called modules. And in the part with /11 before, we had toolchain and updates of the toolchain inside the core. But now we have the core, the compiler GCC version 4 in the core. But we update in the so-called toolchain module the compiler and add step as a second version. That you can choose whether you want to use the one where we compile all the packages with, or whether you want to take the newest and greatest compiler that might have some that gives you additional features, but might force you to change your code because it has these additional features. So you can choose what you want to go on in per application basis. And as part of that, we are delivering yearly. Right now, we stuck, so August, September timeframe comes out a new toolchain, because that's when GCC 2 release always comes out, and afterwards we release that. And I come more to that one. So this summer's update included GCC 6.2 with C, C++, Fortran support. Also the new binutils, the tools that you need for linking and generating assembler, writing the debug information and so on, and the new debugger. We also have submodule supported. So we support, if you are a developer or an ISV working on software, if you run into problems with that new toolchain, we will support you with that one. And I give more at the end to explain that one. We also have speaking about compilers, we have package hub, which are curated packages that are available in the build service, made by third party, made by colleagues, by open source community, that we tested that they work basically on a base level, can be installed on top of SLES, but they are completely unsupported. And those contain, for example, the Google Golang compiler or Erlang, Glasgow, and Haskell compiler, GHC, also R project for statistical computing. Those are included there and available. Okay, comparing that one with how we did it with SLES 11, I explained already that we had updates there as part of the core. So we did with every service pack, didn't update. Delivered the new toolchain unsupported as part of the SDK, and delivered the runtime libraries, and so on as part of the core. But there was no support for the new one. So, question is how to use the tools. The binutils and GDB, they are just replacement for the old tools. So there's no change for that. There's also no compatibility for you. You can safely update. And we tested as well. For GCC, we add the version number behind that. So instead of calling GCC, you call GCC -6, and that way you can switch. You can pass it as an environment variable, depending on where it is, or G++ -6, and use those versions and change that. So that you make a conscious decision which one to use, and don't, Speaking about versioning, in the past, until GCC 4.9, it was releases 4.0, 4.1, 4.2, and so on. And then they were at 4.9 and were considering, should we go to 4.10 or not? What is the right time to increase the major number and not? All those versioning bike chats you might know about. And so the GCC developers decided that they make major releases every year, as I did before, call them 5, 6, 7, and so on. The development version is always called the .0 release, but the first release is the .1 release, and then the minor release are 5.2 and 5.3. So 6.1 came out in May, I think, and 6.1 and 6.2 came out in August. And we wait for the second release, since we test the toolchain complete in our open SUSE distribution and compile all our thousands of packages with it before we give it out to the customers on the enterprise level and say it's safe, it works, to rule out any bugs and also get those bug fixes into the upstream release so that we can safely deliver that one. So look at new GCC 6. What's new in there? Compiler optimizations, support for CPUs, new language features, and diagnostics and debugging. The major change for GCC 6 is on the last point, on diagnostics and debugging. It's got some of the changes that other compilers do. So now it is really colorful and explains you here as a display of wrong code, exactly underlines this instruction, this star is wrong, so there's no match for the operator. So you can see directly that's the place that's wrong and don't need to look into a long line, which line 70 is broken, but what's in there? I don't know. There are several places and you don't know what it is. The same here with the printf form. It highlights exactly the column, the character that's broken, so you know what to change and can look at that one and update it. But they went even a step further, so they added some hints on how to improve the code, on how to fix the code. It's not a pointer. Also, pointer is a pointer, so you don't use a dot. Perhaps you mind to use the minus and the greater sign here instead, and for the pointer notation, and suggest how to fix that one. It might be wrong that pointer shouldn't be a pointer, but I guess in this case it should be. So those fixed hints are quite important. It can also do that on field names. So if you're misspelling color and have it in one code, it will tell you, hey, was that really shouldn't you use that one? So it looks at the existing fields and does a pattern matching, a closeness match, and figures out that one is closest to it. So propose that one. Compute some. Is it the Hamming distance? I'm not sure. Other things that are used. If you have looked at one of the, I think it was at Shell Shock, where they had two gotos below each other, where the intention expected here's all the checking done. So the author intended the code to go there. If it's not equals 0, go to fail. Otherwise, do more checking here. But due to the second go to fail and not using braces around that one, that go to fail was used in both cases, and the complete checking was skipped, and we had a vulnerability. So nowadays, if you compile that code, you will get a warning. The if clause does not call, so with misleading indentation, the if clause does not guard that one, the statement, but the letters as it's guarded from the indentation wise. That's an optional warning. No, it's in WAll, so it's enabled by default for if you go for all warnings, and found quite a few problems on that one, and also found some false positives where people just used the wrong indentation, but code was correct. But that's always a code. On a style-wise, I think it's a good way to include that and take care not to hit those problems. There have been more warnings added, so there have been sanitized options added that look at undefined behavior, and that one has been enhanced looking at threads, looking at strict checking of array bounds, whether you're writing or reading from outside of a defined array, but also on left shifting of a negative value and so on, overflows, or whether a comparison with self, which is always constantly true or false, depending how you do it. Those things are fixed or will give a warning, because they normally, if you have a code that always evaluates the true, that can be wrong in some cases. It also detects paths where you're dereferencing a null pointer, so it does value propagation and sees, okay, in this path the pointer has a null value, but you're trying to dereference it, so that's undefined behavior that might crash the code, and you get a warning about that one. It can also tell you about duplicate condition in if-else-if chain, which normally are not intended that way. So all of kind of problems that you can run into, and that helps you to write better code. I thought there was another one coming here. Okay. I was misled by the title, sorry. So, speaking about the null pointer check, GCC is much more aggressive now in optimization and eliminating in value propagation, eliminating code. And in some cases that can be wrong. For example, the value range propagation can check that a pointer is non-null, but there's code in Chromium and kdevelop and Qt5 that depends on certain behavior here and puts even into null pointer something in there, and that breaks with that one. So you have to disable that one. So no delete null pointer checks, or use fsanitize minus undefined to define that. So compiling those larger programs isn't the best idea with that option. On the other hand, if you have confirming code, it will make your code smaller and make it faster that way. For optimizations that were done in GCC 6, we have link time optimizations, so figuring out at link time, looking at the whole program, at the whole file, how it all works together. A lot of robustness fixes went into that one. And now also C and Fortran code can be mixed, and there are compatibilities between them. And we have much smaller object files that are generated as intermediate steps. So we have reduced those size by 11%. The interprocedural optimizations that you can do on a whole file or on multiple files as part of link time optimizations. Function cloning is now much more aggressive, which helps you to do further optimizations on a function. If you inline the function, complete and clone it, and then go through it and figure out how this is. But also the heuristics for using the interprocedural optimizations have been improved. For threads, OpenMP and OpenACC is now supported in newer versions, and some work went into that one as well. On the CPU level, not much exciting was happening. Intel, ARM, Power, IBM brought up new architectures, or promised to bring them up. At the point of time, I think IBM Z13 is still not released, and Power 9, when the code came out, they weren't available. But we have for x86-64 Intel added for Skylake 512 bits extensions that can be used for vector operations. AMD has brought up with a Zen core new features in their CPUs that need to be taken advantage of, and also the instructions need to be scheduled. And the segment register can now also be used in a specific way on those CPUs, but that's more a rare use case. On x64, we now have link time optimization support. That wasn't there before because that needs changes for the CPU. And optimization for specific processors have been added. On Power, we have vector support. That is part of Power 9 and general Power 9 support. And IBM had brought out with that system in Z13 specific new instruction that needs to be supported as well. On new language features, GNU, so ISO-C at 11 plus GNU extensions is since GCC 5 the default, and that's the default also here for us. And on the C++ side, the C++ 14 is the default plus GNU extensions. As with GCC 5, we have now in lib standard C++ for C++ code a dual ABI that is has a new ABI that is standard conforming. We have kept the old one for old binaries. So it includes, for example, a standard list implementation with an order of magnitude 1 size function. And since we broke the ABI at one point, the developers also included a string optimization that uses different way of setting up the strings. So it uses the small string optimization instead of copyright reference counting, which broke a couple of C++ programs, including our own Yast, that was depending on the old implementation. We still use with SUSE Linux Enterprise 12 with the updates the old API by default. If you need to use the new one, you have to get compiler flags. Since system libraries that are in the system are compiled with the old ABI, and you can't mix and match code using one library against the old one and one against the new one. You can't pass string around from an application that uses a new ABI to a library that uses the old ABI. That will give breakage. So you have to be consistent there. But if you're developing an application where you control all the C++ compiled libraries, then you can easily switch. But that's a caveat to have. If you are compiling and optimizing for, if you're compiling but want to optimize, there are a couple of tips. You can, on the one hand, if you're compiling on the machine that you're running it later on, you can just say -mark equals native, and that one will optimize for the current machine. so you don't need to figure out what kind of machine you have and run it there. You can also optimize, if you want to optimize for a pool of machines, you go for, figure out what's the llama, use the mark flag and select the most common denominator of all those platforms that you have. So go for the lowest one. And then you can also use the mtune one, which says mark, what kind of instructions should I use? And mtune, how should I tune for which one should I tune? And those one you can play with it and look at that. Or you just leave it as it is, because the defaults are that it works on a broad range of platforms. Optimization flags, you can use O2 and O3. You can also use OFast if you run, and OFast is a trick that is used to support, for example, spec CPU benchmarks. We are only allowed to pass a certain amount of flags to the compiler and use that in all settings. So instead of saying, I want minus O3 and minus F fastmask and some other stuff, you just say OFast and can then add some more, because you have 4 slots that you can use, 4 different flags you can pass. And if you use already 2, then you have only 2, so it's only 1. And that gives the defaults. That's the usual tricks that every compiler vendor does. It includes some unsafe optimizations, so safe optimizations for spec CPU. It works, it has been tested there, but it might not be safe for your code. You can run it or look what is included in OFast, and if it doesn't work, then there are some optimizations that might not be completely safe, like the fastmask optimization that breaks the SUSE requirements on mathematics, but which work fine on spec CPU code. It's good enough for that one, because it doesn't make one. For speed optimizations, you can also do feedback-driven optimizations, or feedback-driven optimizations plus whole program optimizations. And feedback-driven optimizations is basically you execute the program once and let the program write down which path was taken, which values have been used in certain conditions. And afterwards, you run the code again and optimize for those for the previous runtime. So you do that, the build first with fprofile generate, and then you execute the binary. It outputs at the end the profile file with all the information that is necessary, that will help it going forward, and then recompile the binary using the profile with fprofile use equals program.gcda, and then it will know this if condition is not used at all, or is only used in 1% of the cases, so move that to a cold path. And this is the hot path that is used, optimize that, and those are common values, optimize for those, and so on. Has more knowledge about that, what's common use case, what's coming in and what not, and can schedule for that and optimize for that. Keep in mind that profiling collection is not thread safe, so if you do that with a threaded application, GCC might complain that some numbers are not counting up to 100%. So it will still work, but GCC is not happy and gives a warning. But you can still ignore that one. And the other part is link time optimization. So instead of, normally you compile a single file, optimize that, and at the end link everything together without any looking across the files. But with link time optimization or whole program optimization, you look at all files together and know from there how certain functions are implemented, but also what values are used. And to do that, as a first part, you compile the single files into an intermediate code and use that one. That's the so-called streaming presentation of the code. And then at the link time, which was in the past very fast because it just concatenated the files together and resolved references, now the real optimization happens on that intermediate representation. and that allows interprocedural analysis across files, function cloning across files, value propagation across files, which can be quite a benefit for some programs. And to use that, you pass the -f-LTO to your files during compilation. That's all you have to change to add this single parameter, and at the end you link and edit again. And those O files that you have here are now quite a little bit larger, or quite a bit larger compared to what you would have expected. But in the end, you have a program that is faster. But you have to take care of that it might also be much more difficult to debug, because the debug information to get that across and get it annotated properly across files, there's still a couple of bugs and design decisions where either compiler or debugger need to be improved so it works perfectly. So if you need to debug that, in some cases, you won't say, I don't want that. But give it a try. If everything works fine, okay. And it should work in most cases. Another thing completely unrelated to that one is vectorized mathematical routines. In the past, you could download the Intel or the AMD vectorized functions, which allowed you, for example, if you have an do the sign calculation or the square root calculation on a number of values instead of on a single value, and then iterate on that. We have an array of that for that one. But now the code can be parallelized by the compiler, and the compiler knows about that those routines are in the C library and can take advantage of that one. So, as I said in the past, you need to download some Intel or AMD library and place it in and add some obscure compiler flags to get it used. But now it's all implemented and integrated. And that one is only available with a glibc from SUSE Linux Enterprise Server 12 Service Specs 2 that we announced this week here at SUSECON, and which will be available next week. So it won't work with older code. So if you want to look up any of that, there are pages on the GCC website that explains on the one hand the changes, but on the other side explains also what needs to be changed for porting, where the standards are more strict about how you change your code. GCC 7 will come out next spring again. If whenever the release team is happy with the current state of the product and has fixed all the bugs. So it's currently under development. The highlights that I've heard from what's going on is further fixes, further hints on how to fix code and improve code quality. LTO debugging to improve that one and make it easier to do, on whole program optimization to debugging. There's also, will be in there, or should be in there, is planned to be in there, let me say it this way. I've known that there is experimental support for the first features of C++ 17, the next upcoming standard. Experimental because the standard is not released yet, but they implement it, and so that they know when the standard goes out, have experience with the features and can say, yes, we can put that into a standard, it can be used. And the C++ community, standard community is quite happy to have it in there because they get early feedback. And GCC is often one of the first to implement a new feature. We plan to release GCC 7.2 in summer, late summer, whenever it's released and packaged by us and when through QA. So you can expect a new update there. So looking at moving from GCC to the toolchain below that is used and is normally not directly interacted with. Why update that one? On the one hand, GDB needs to understand perhaps new debug information by the compiler, new ways what was generated, and gets fixes. And binutils needs support for the new toolchain, but also support for new CPUs and new instructions in those CPUs. We are using, we have released as for everybody as an online maintenance update in summer GDB 7.11.1 and binutils 2.26. For GDB, I think the major changes were thread signal handling has been improved. So the user gets now informed, for example, which threads triggered an event. That was before not easy. Before that, you had to figure that one out. There's a different syntax also for setting breakpoints. So instead of setting a breakpoint on a function, you can also now set a breakpoint on the file main in line number 3. That was before that not possible. So first I have to look at what's the function name, where is it? So it's an alternative way of doing it. You can continue and say break on the main function, but you can also say break on that single line I have here. And it includes bug fixes. With binutils, big changes is here for compressing the dwarf format, the debugging format that is used. It's currently supported by the assembler and the linker, and the other tools are going to use that one as well. And we are testing, we have enabled the compressed dwarf format in OpenSUSE already, and we'll do that in future releases perhaps as well, because it shrinks the size of the debug format. Since it can compress that, it can shrink it significantly. I did some testing, but I forgot what the number was. No, I think it was a good improvement on the kernel where we checked it, but I forgot the numbers. And yeah, that's it. So if you want to compile software and distribute that one, if you want to use it with the new Toolchain module, it will run on any updated Slate 12 system, because it needs the new standard C++ libraries, the new libraries, or the runtime libraries of GCC that have been distributed as an online update. But anybody gets that as by default and uses that one. If you're looking at support, support for the Toolchain module is available, and it's available via the usual channels, so you can ask for that, open a support request. If you do, if you open a support request, it helps a lot if you have some self-contained code and say this code is wrong. So create some kind of example that the GCC team can look at it and can reproduce it, instead of just sending snippets. If it's executable, they can look at that and see it. The team is looking at the normal -G and -G0 debugging flags, at the O0, 1, 2, 3, and fastmask and O-fast optimizations. And those are the focus of that. If you use any other compiler flags, they might say, okay, it works with -O2, use that one as a workaround for now, and we'll fix that going forward in the upstream release. But they will help you figure out what the real issue is and file the bugs. And depending on what it is, do an online update and maintenance update of it. Speaking about Go as programming language, it's a language that has been developed by Google from some of the old Unix guys, and in 2007, so it's 9 years old, an open source programming language that is designed for a specific purpose, and mainly designed for writing servers, so not for GUI programs. And it's compiled, it's statically typed, it comes with garbage collection like most modern languages, with memory safety and concurrent features to write web applications mainly. So why developers are using it? it got quite a hype because Docker uses it. And as part of the Docker hype, people are looking at the language that Docker is using, which is Go. And then it showed that it's an attractive language. It's much faster than shell scripts, and it's easy to do some of those applications as well. It's in some ways more powerful than C, but you don't want to write some. I wouldn't use it for system-level programming or for desktop or GUI-based applications. But for network and web server, that's where it really shines. This is concurrency with its way to specifying network and the other features, also for send-line, command-line programs and scripts. We're using Go internally at SUSE as part of development of Docker and Kubernetes. And we also have a project called Machinery, which is mainly written in Ruby. But we figured out at one point that we are inspecting a different system and need to run had a very large and complex shell script that we needed to push over and fix that. And rewriting that one in Go sped up that process by a factor of at least 10, so by order of magnitude. That's where going from a shell script to a static program, in that case static, so you can execute it everywhere, helped us a lot going forward and using it. The latest release is Go 1.7, and that's also the first release that supports all our architectures that we use for SUSE Linux Enterprise 12. So it supports the 64-bit ARM platform, PowerPC, the AMD Intel platforms, and also the Z systems. And that is the new platform here. And it includes a new compiler backend. That one will be soon available as part of the package hub. And we will use it internally as well to compile our Docker packages for all platforms with that. Right now on that we use GCC to compile. It has a Go language implementation in it, but that is not as major as the Go one. So standardizing on a single version there will help us internally as well. So the compiler package is named Go, and you can add the package hub with all its packages through Yast, via Yast, to your packages, to your system. Right now we have at that URL still Go 1.6, but that should be updated soonish. Speaking about modules and the Toolchain module, we've done with /12 several modules, including the Toolchain module and the yearly deliverable, that you need at install time, need to look at the modules, do the extension selection after registration, and then figure out which modules you want. And that screenshot was done before we released the first version of the Toolchain module, so it doesn't show up, but we'll have it here and it will be added. And those are all included in the subscription, so you don't need to pay extra for that one. So sorry, I planned to do it interactive, but then I went in presentation mode, sorry. Do you have questions, comments? How are you using compiler?
I usually play a system admin role, so I was mostly in this because there are times when I have to sit with application developers, and a lot of these terms are used. I know most recently they started using Go. My background in development is very dated. So I don't have any questions.
Okay.
Are you delivering a toolchain delivered, I guess, at this point, technically, with 12SP2?
So we deliver with, we have the GCC 4.8 that was on the GA version, and we deliver that, continue to deliver that with /12 over the whole lifetime. And the additional update here, GCC 6 right now, if we release the summer, is an additional compiler. So we have both. We compile our own distribution completely with GCC 4.8, with the exception of the / for ARM platform that we announced this morning. That one will compile with GCC 6, because there are a couple of fixes in there, essential fixes for the ARM architecture. Backporting them to GCC48 was so much work that we diverged from our common code base. But in general, you have both compilers and can decide which one to use. And we build our own tools with GCC48 because that's how it was delivered. And each new compiler can, since it includes new language features, it might mean that your code is broken in one way or the other and you need to touch it. And for us, touching 3,000 packages wasn't worth the risk. And then we would need to test them all and so on, or even those we haven't tested. So we stay with that one compiler. And if you're on ISV, you can continue with that as a developer, use GCC48, or you can choose and go to with GCC6 if you want. It's an additional option.
How about some of the other modules that you have put up there aside from just GCC1 itself? Is there a way for customers to request things to be added to the toolchain modules? Like how do things get chosen to put in there?
Right now we have in the toolchain module just GCC. We've been entertaining adding Go into that one. So for now we put it, since everything here in the modules is supported, we decided for Go with Go 1.7. We use it internally, but we don't want to support it at this point of time. So let's make it available via the package hub, unsupported, still the same version that we use internally. So there's no difference, but just labeling unsupported. But those are things, if it's for the toolchain module, yeah, talk with me. Feature requests via, if you have any SUSE contacts, put them in, and we can look at that. So far we try to make it small, but if there's good feature requests, surely we will look at that and see. Do you have anything specific in mind?
Actually, I was more on the other pieces, like
okay.
web scripting and things like that.
Yeah. So we add what that all of that grows depending on discussions we have with customers. So we are adding now to the advanced system module. Salt will be released now. We had a couple of hiccups to get that out, but that's coming out, I hope, before Christmas, finally. So we enhance those based on internal and external discussions we have, and that's that. But if anything is missing, just tell one of, talk with one of the Slash guys at the kiosk, for example, or report it. Okay, anything else? And thanks for staying in.